The first 3 weeks of the eruption here in Hawaii, crazy things would happen in the middle of the night. A new fissure would open up and it would threaten a new neighborhood. Thousands of people were evacuated from their homes. I started the Hawaii Tracker Facebook group to help people understand what's going on and get their questions answered.
Hey, how's it going? We're live. This is Fissure 20.
We had hundreds of people all throughout the neighborhoods sending in videos, articles, and images. We spent a lot of time making sure the accurate information gets out.
This is live. Still lava moving.
They weren't just sharing a story, they were helping their neighbor. If a family was being evacuated, my group would just jump in and help out. So it was huge. They were watching out for each other.
Hello everybody, thank you for coming. Thank you for the support from everybody.
As we go through this, we're growing closer together as a community. When tragedies like this strike, you really realize how much you need each other.
Aloha everyone, I'm geologist Philip Ong, here with Mr. Dane DuPont of HawaiiTracker.com, bringing you guys another Hawaiian Volcano Tracker update. Today is Wednesday, January 18th, 2023, and the story is that Mauna Loa is still quiet, not a whole lot to say there. We'll touch base if we have time at the end here. Kilauea has stabilized over the last week, Dane. It looks like the lava output may be stabilized, the gas emissions stabilized, the lava lake size is stabilized. It does maybe appear to be linked to the deflation-inflation events, possibly. And it does overflow whenever it seems like we have an extra little bit of pressure there. But that's been the long and short of it here. And otherwise, our schedule has been quite busy. Yours in particular there, chasing around Volcano Awareness Month talks across the island here. So would you like to share a little bit about that and your thoughts for this week? A little louder, please.
Yeah, we had some good presentations that gone to so far. Slightly not well attended, really. Like to encourage anybody around that's hearing this to maybe attend some of these things. But we talked about the Kilauea faults, particularly around the Great Ka'u fault. And then we also talked about yesterday was a presentation about Hualalai and the impacts on South Kona area, and also Maunaloa was in there as well, a little bit about the previous eruption. And the Hualalai section was interesting, going to try and do something with that. But that's on stream if you guys want to check out the video of that.
Yeah, I thought that the fault one was interesting as well. That's the Kilauea fault zone there. That's that connector zone south of the caldera between the southwest rift connector and the southeast rift connector. But we really are going to have a shorter schedule today because there's another talk coming up in a little less than an hour here at 6 p.m. Hawaiian time. It's going to be streaming on Naleo, the nonprofit cable channel, and we'll hopefully share the online link to that as well. But the point being, we are going to get through our program pretty quickly here and not go into a lot of the other details. We're not going to cover the recap in any of those presentations today because of that abbreviated format. And rather, we'll just jump into what's happening with Kilauea for the most part here and rely heavily on the time lapses that we've seen in the last week here. Anything before we jump into it, Dane?
Yeah, just last little thing. I think I mentioned that stream was on YouTube potentially. It was on Facebook. It was in the Hawaii Tracker Facebook group. We're going to try and edit something out once I get the slides and be able to actually see what was being presented.
Right on for YouTube. Right on. We appreciate that. So we'll look for that in the weeks to come here. All right. So let Dane know if you have any questions, any issues with our audio or video. He'll be leading the discussion in the chat. And otherwise, I'll transition here to our Hawaiian Volcano summary. And what you guys are seeing on screen here is edit from the S1 camera, the nighttime views only, just for this past week. And I thought this might be one of the easier views to really see this pattern of stable size of the lava lake and the overflows that are occurring off of the edge of it there. And this is vastly sped up. You can see there are times where there's a whole bunch of overflows happening all at the same time, and other times where there are not. And so we'll dive into this, but this is the summary slide here of what that actually looks like. And we do have the live camera still going, so let's take a quick peek into that. The views have been off and on tonight depending on weather coming in. There's been some mist and rain, but there you can see there's that persistent area of fountains that's still coming up through the crust of the lake. You're starting to see this raised edge. Those are the levees that are forming around the lava lake. And when the supply is higher, that's what's getting overtopped, and the lava is overflowing over top of that to feed those big flows, big fan-shaped flows on the crater floor here. So that is it. And then just to recap here, here's a Volcano Awareness Month calendar, right? So we've mentioned the fault talk that was at Hilo last week Thursday, Ocean View on Saturday. Dane was in Kona yesterday, and tonight, Naleo Maunaloa 2022 eruption and response. So that is the long and short. And turning to Kilauea here, let me get the right title on the screen here. We're going to do our Kilauea monitoring first, just to mention the updates. I'm not going to go through all the different updates from the last week, but today's, because they're fairly similar, so today's is up to date enough for us. No significant changes have occurred in either the summit or either rift zone. Activity is still concentrated in a large lava lake in the eastern half of the crater, as well as a smaller lake to the west in the basin of the 2021-2022 lava lake. So I've been calling that western pit. There's also a central pit that's east of the island that we'll point out in time lapses as well. So back to the update here. The eastern lava lake has one dominant fountain measured at 6 to 7 meters or yards high in an area of approximately 30 acres as of January 10th. So that's over a week ago now. However, the surface area did not change much over the past 24 hours, though a series of short-lived overflows occurred onto the crater floor yesterday evening. They've been mentioning since Saturday some overflow action in the update. But otherwise, it's pretty similar every day, these updates. The tilt meter is changing day to day. There are deflation-inflation cycles that we'll look at here shortly. And volcanic gas seems to have stabilized to the most recent measurement, January 9th, at 3,500 tons per day there. Just to point out here, no unusual activity in the rift zones. This is where we're sourcing all of our information from the USGS, and hopefully we can explain it by showing you guys some illustrations here. So here is Kilauea monitoring. This is the 1 week summit lava depth. The eruption began 2 weeks ago now, so we're only seeing that second half of the week of lava depth, and there's a jump here that we haven't had formally explained yet. We suspect that maybe the point at which the laser rangefinder was aimed was moved, because it used to be aimed in the western part of the lake, and now as we know, activity is in the eastern part of the lake, and therefore you probably need to recalibrate that somehow. So we haven't exactly heard, but that's a suspicion that I have there. In any case, despite that little change, you can see that the It's been a steadier rise. If I zoom in here, occasionally you get a little drop, but for the most part, it's been a steady rise, and then you can see coming up this larger increase here in a recent day or so. And interesting, it does have a little wiggle in the middle there too. So all this means is that when you have those levees around the lava lake has been stable in size, so that allows the lava on the edges to kind of lap up and pile up in the same place over and over. That's what forms the levees. That allows it to pond higher in that same area, and then when there's more volume, it has to spill over there. So go ahead.
Is that a drop off? Could that be one of those ponds that like a breach, a breakout, and it draining in that section where like the rangefinder would be pointing, maybe?
For it to possibly for that downward one, right? But the upward signal is the one in question here. So you could maybe it went up and then this little double dip in the middle here, that maybe that's one of those overflows, but it's not quite clear, and it's so close to the calibration zone that I still have suspicions there.
I was thinking more towards the recent little dip and bounce back.
Oh, over here, yeah. Could be that there was a little draining that dropped the level down slightly here. Yeah, that's possible.
Right. That other one, I think you're right on that. That's recalibration, moving the thing, stuff like that. But that drop, I'm thinking maybe a perch pond break.
Yeah, so zoomed into the last week here. Here's a deflation-inflation cycles on the summit tilt, right? So we did have a couple in the last few days here, and the most recent one, the inflation began yesterday morning, and then came up higher, and it seemed to stabilize there, right? But you can imagine this is when you're getting the most lava getting put into the pond there, is during this phase, and so it could have breached slightly delayed up here, potentially there. So it's a little easier to look at on a 1 month plot. Here is that overall 1 month plot. The eruption begins right in here. So there is that. Seemed like some earlier calibration happening here, and then maybe some other calibration. It's not quite clear exactly, but there's a couple of these interesting signals. Overall pattern being up, of course, and these little jumps up and down are a little more suspicious. But I've lined up all the different monthly plots in a row here today so that we could try to compare. So there's that beginning of the eruption, the lava lake coming up, the tilt signal that began the eruption. And if I zoom into it here, these are the two most recent deflation-inflation cycles. But you can see there were a couple other ones that occurred about a week ago. So kind of, a couple that were about a week ago, and then several days of gap, and then a couple more in the more recent days here. And if we try to average out those signals, maybe we're stabilized, or maybe it's slightly downwards, but it's a lot flatter than it used to be, and it's also not showing any evidence of it bulging or anything funny happening down there. It just seems like it's found an equilibrium outflow here. Earthquakes under the Kilauea area, you can see they were building up ahead of that eruption breakout. And since then, they've been in this low level, right? Some slight variations in here as well, but nothing really major to speak of. SO2, it was low prior and spiked high. We're not sure what the actual peak emission values were. Maybe we'll get one of those satellite integrated measurements here at some point. But the highest individual measurement was at 12,500 tons per day back on the 6th. And the following day there, it was down below 10,000, and really the last few days here, it's been below. This is a 4,000 tons per day line. The most recent one, 3,500 tons per day. I want to say that maybe this one on the 9th. So maybe a little lower than that too. So pretty stable, right? Dropping off pretty fast, and still coming down a bit, but definitely seeming to be hitting this plateau there. So that's where that stable gas output comes out. Unfortunately, that's enough gas to still cause 4,000 tons per day, still enough to cause a lot of fog and a lot of issues, so we'll cover that here in a bit. Looking at the whole last year, here's earthquakes, with the recent run up here and that recent drop off, and then gas values below that, showing that tail off of the previous eruption that was at 4,000 tons per day back. It looks like it was at 5,000 back in February last year, and so much of the first half of last year was in this range of 4,000 tons per day-ish, and then when it came summer, it started dropping down a little bit lower after that. So here we are back at that same level, 4,000 tons per day. And This is interesting that we've seen a response on a summit GPS. This is the line length north to south across the caldera. So when it's going up, it means the sides are getting further apart, the volcano is swelling and bulging with magma underneath it. And when it's going down faster and then maybe slower here, something like that, right? If I were to try to guess, that's showing the sides coming closer together, right? So that there's a net release of magma from underground, right? So the eruption is accomplishing that work of getting all that built up magma onto the surface and relieving that pressure, and it's getting out enough, right? Probably getting out more than it's building up underground at this phase in the eruption. And this is something we usually see turn around at some point in time. At some point, the nozzle starts closing off, or the output declines for some other reason, and then you see the tilt and the GPS start to show spreading as magma builds underground and collects and doesn't all get out at the top. So we haven't reached that phase yet. We're still in the early phase of this eruption, where we're still seeing that deflationary trend here, which is interesting. And just to note, on the upper Middle East rift zone here at Pu'u'o, we're seeing no evidence of any change, right? The pattern hasn't changed at all, despite all the stuff that's happened, both on Kilauea and Maunaloa. And there's some little wiggles in here, but really the overall pattern you can see is remarkably unchanged. So in Kilauea over the last week, here's a map of the earthquakes. The south flank ones are ever present as usual. These smaller ones background over here, nothing to worry about, nothing unusual there. Pahala still ongoing. We can discuss that more some other time when we're not so crunched for time here. And Kilauea summits, what we're going to point out, that these earthquakes are continuing a little bit at these lower levels, but this is where they actually are here, in that Kilauea area. Lots of small ones. So if you look at the GPS and the earthquakes combined, maybe you're seeing some response of, that magma leaving the underground area to the surface, and then the ground that was bulging underground before that is now relaxing or swelling or adjusting in whatever way that you can imagine in there. So that is our Kilauea monitoring, and we'll stop it at that and advance here to the primary hazard of concern, which is the gas. So here's a VOG mapping, the VMAP project forecast here. And that is our Kilauea emission source right in here. And they're putting in 3405 tons per day as their emission rate here on a little input box. And so you can see over the next couple of days here, VOG is forecast to cover from South Hawaii, South Kona, through the saddle, up past Waikoloa, Waimea, Honoka, Pauilo. Hilo looks like it's like missing most of it, right? But you get the uplands of Hilo area, and Honoka is, you can really see there's a forecast for VOG to be everywhere in the next couple of days here. And it already has been over the last couple of days as well. So interesting that the effect of the eruption is felt not really that close to the eruption source right in here all the time. Obviously more frequently so, but there are times like now where you see all this orange and yellow in the saddle and Kona side here showing where the VOG has been going here. So not to belabor it, I'll just come to the national park site and we'll look at lava viewing in a bit as well from a national park, which is still good. And here you can see that the Art Center in Volcano Village has SO2 peaks this morning, and I'll scroll down, everything else is in the green. Kahuku over in southwest Maunaloa, South Hawaii, showing SO2 right at the summit. The steam vents, Kukamahuakea, showing SO2 spikes this morning and late last night, both. And it looks like we got a couple of stations not transmitting, but you can see that it is coming and going. And so certainly if you're going to the park, you want to follow the guidance for air quality and all of the instructions from the rangers. Okay, so now we'll switch to our webcams and our visual observations. And we'll start here with this F1 camera compilation. This is zoomed in, but I'll have it for the whole eruption here. So there is that earlier large lava lake during that first week where it's really receding. And you do see some kind of pulsing. It kind of contracts back towards the center and then comes out again. And that's those early cycles of deflation, inflation. Here we are about a week ago, and there you can start to see these overflows, these little pink tongues that come off the side. And camera goes a little crazy. I left it in there because you can see the movement a bit. There was another one of these big overflows. You can see just kind of they splotch over the edge and make a big fan, and that stays hot and cooling. But that flow is basically over once that overflow is cut off. So there we go. That's that most recent time here. I'm going to pull it back for about halfway to start for the whole last week again. So you can see the fairly relatively stable area of the lake once again. The overflows coming off the side. Back over here as well in that front. This is that central pit that I mentioned. This is where that original eruption fountain came up. So that seems to be open and connected through some underground pathway to this main lake, and that pathway seems to also feed back into this western pit, right? And it also has a little pit to the side that's connected through a lava tube there too. So that's that interesting pattern you see there. Now we have a similar view from the KW camera. This is zoomed in as well, so there is that earlier wide angle and that western pit, southeast pit there. Here's the west vent complex still glowing. And once again, I've taken only the nighttime views from the KW camera, so you can see it really shrink in here. And then overflows begin. There's one, there's another. The fountaining source is persistent that entire time. You see there's a gap, right? You see a couple overflows, and here we are in several days of no overflows, and here comes a whole bunch on the morning of the 18th, that's today. And if we go back to the monitoring graph here at the top, right here today, there is that peak of the inflation. So maybe there's some correlation there. I'll have to try to link that a little better here. But that's the KW camera. Let's move on to the B1. And what I have now is super fast zoomed in and just a daytime views. Right, so we start off with this hornito here that was on a crater floor before this eruption. This was a measure of the height. This thing was thought to be somewhere in a range of 30 feet tall or so. I really sped it up quite a bit, so you can see it actually gets bulged up, surrounded by lava, and then you start seeing this dark feature that's the levee of the lake forming on both sides here. And I really wanted to point this out because you really can see that even though that formed an islet originally that was within that lava lake, the lake contracted to be outside of that, formed a levee just next to it, and the levee's been overflowing over and over and over. And it's hard to always see this pattern building up, but what's really cool is you can see this whole islet getting drowned and getting buried in those overflows there. So that's pretty clear, I think. Whereas it's not always easy to see that there. So if I play that same view, not quite as fast. There it is, popping up. There's that original islet when the lake was covering a whole crater floor. You can see a little bit of sagging there as it retreats towards that center outlet, persistent fountaining area here, forming the levees. You can see occasional overflows. Those flows fan out, and then they seem to kind of sag and cool, right? They're like a one-shot deal. There's no lava continuing to feed them to cause any inflation and swelling and bulging like we've seen elsewhere in Kalapana or things like that. It's just like a one spillover. Spreads out, degasses, and then sags and contracts downwards there. So that was the daytime view of that, and I thought I would also play it zoomed out. So we were zoomed into that little area right over here in the back left, but you can see this earlier phase, how much wider the lava lake happened to be, and there is that little zone I was zoomed in on that was overflowing and getting buried by that perch lake there in the background. B1 camera from the USGS HVO. Mahalo to those guys for keeping these running as much as they do, which we know is a challenge. Yeah. All right, so just to be fair, here's a nighttime view from the same camera, same wide angle, just nighttime shots only, showing that retreat of the lava lake and then stabilizing about a week ago right through there, and then overflow is beginning, and not zoomed in, but that wider angle view there as well. So those are a few of our top cameras. We have some more though to get through. This one is the S1 camera, and this is the last week. Daytime views only, which I thought was easier to just really see the extent of the lake. It's a nice angle. That B1 camera is somewhere up in here, and it's looking off in this direction. So we're now farther around and looking higher, looking further down into this pit here. And so you see that the lake is circulating for the most part. You see some of these overflows, but they're not as easily visible in daytime. But what is visible is this big islet this chunk of rock that's floating around is another one over here that seems to appear in this view here. So let me play it again and start with the daytime views here, and just so you can see zoomed in on this fountain area, what's going on. See it's feeding the flows in every direction. Seems to be gathering mass, and there we see that little islet form. It moves around. It's jumping a bit here because I've taken out the nighttime, and so really I gotta go back and show you guys the day and night view here to really follow that thing. So I'll do that. Here's going back to the beginning of the eruption from the S1 camera, or a single source. I'll zoom it in. So there it is bubbling. We see circulation in this lower part of the frame still now. And it seems like right in here you start to see something collecting and starting to emerge. There it is, right? And this is an area that might have had some less dense rock, perhaps some of the cinder from the eruption or from a previous eruption or the original first eruption. In any case, it seems to rise to the surface here. And clearly it's not anchored, it's floating. It seems to be drawn towards the fountain, something we've seen in previous eruptions as well. And then once it gets there, it's kind of bobbing around and it's finding the best place to be in relation to the flow that's emerging from that fountain zone right in there. So really interesting to see that. That's where that one seems to rise out of the lake right through there. And there are more to see than that. But to do that, we're going to turn to the V1 camera. It's the last camera in our lineup here. So here is similar to that live view, right? But we're really speeding it up and showing you guys all the last week here. So day and nighttime, there's a single fountain. You see the flow is consistent away. There's a chunk here in the foreground. It seems to be moving a little bit slower. So there are some chunks of more solid rock that are getting pushed along and not moving quite as fast. You saw a little overflow come in very quick there. You'll see some other ones. There's one below right there that happened in the daytime. Keep your eye on this front edge here, and there's another one there, and another one there, and we actually see the islet come in, and there's one right there. There's another one pops up in the background, and actually starts moving and drifting away, and resubmerges through there. It's actually a little bit submarine shaped. And here at the end, we actually see another one of these little islets come in at the background. I'm not sure if I can adjust this to actually show it in the right frame here, but it'll last a little bit of the sequence here there. So there's that last one there at the end. So make it a little easier. Here's a little trim of this island we just followed on the S1 camera, coming into view, rotating, getting close to the fountain. There it is, bubbling. You can see there are times like now where it seems to rise up and out. It seems to become taller. And then as time goes, it seems to settle back in. And maybe I'll zoom that in so you can see a little more easily there. Well, here it comes, spinning around. It starts to rise and emerge out of the lake right in here. And maybe it's getting close to that fountain where it's collecting some of that gas-rich lava underneath it, causing it to be more floaty, and then releasing it again, causing it to sink. It's hard to really know. Just really fascinating to watch that happen there, right? We can see relative to the back wall of the crater here, right? Some changes as well. So look at the wall back here. You'll see this thing actually cracks and drops in. Where is it? Right, and right there it goes. And there's a chunk in here. So you see that this is the wall that's sourcing these chunks of rock that are floating through here. So some of those overflows are also gas rich and are causing that less dense rock that's floating in here. And maybe it's not that much less dense, and so it's right at that point where any small difference can cause it to rise and fall and bob around in there. So that's the bigger one. But if I come up here, let's look at this other little submarine islet, and there it goes, drifting off, does a 180 turn, and then spins off and sinks back underneath there. Let me zoom it out a little bit so we can follow the whole thing. So you see there's this little nub on the edge of the lake right through here. There's a little embayment, and this is a chunk that breaks off and goes floating. There it goes, spinning, drifting, and submerges back in here as well. So interesting to note, those changes are all minor changes on a lake surface. One last pull out to mention here. This is courtesy of 2 Pineapples, who have been live streaming the USGS views as well. So catching one of these overflows down here. There's a fountain in the foreground there, and there is that overflow over that levee of the increasingly perched lake here. I'm going to zoom it out a bit. Let's go to the next overflow in a sequence here. This is all from January 15th, and mahalo Lunana for all your work with all the recent events, as well as continuing coverage of the eruption. So yeah, I guess I started halfway there. So let's put it back at the beginning. Here's a nighttime view, and then there's one that's beginning right in there. There's another one back over here on the backside, starting to go off in that direction. But there you see that fan coming out. So really interesting. I was trying to look at more closely if I could see pieces of this levee actually collapsing and breaking, of like some kind of big flood coming out, but it seemed more so that there was just a pooling of lava behind it, and some critical point got reached where it just spilled up and over, right? The crust that was on the edge was able to break and release lava that started spilling up and over, and then that caused the overflow. And once it starts, you can imagine it might push the rocks in that area down a little bit and continue that flow out until it actually can recoagulate, so to speak, right? Reharden in an area. So that was a nighttime view. Here's a daytime view in the beginning of that daytime outbreak. So it just seems to spill over, no obvious major collapse. You see that skin on the top of the lava lake getting carried as the darker parts of the flow there. It really just looks like a plate spilling over there. So interesting. These are the consequences of having levees, right? So the consequence of the eruption rate becoming more steady, the lava edges staying more or less in the same place, building up a little bit higher levees, and then allowing overflows to happen, allowing the levee to break off and create the islets, and possibly some other stuff bobbing up and creating islets as well there. So that's the observations we have for this week. Source mostly from the camera there, and we'll switch to our lava viewing report at this point. And just a reminder to check the National Park Service, Hawaii Volcanoes National Park website. They'll have all the daily warnings and delays and advice. There is still a lot of traffic. The high crowds continue to come to see this really amazing, spectacular view in our Kilauea Lava Stadium, as I like to call it sometimes, jokingly there. Yeah, it's just really a fantastic big bowl to look into and see that. You're kind of far away, but you can see a lot from a lot of places. And that lava lake, once again, is 30 acres, so it's good to have a lot of space to look at. So check that park website. Website's got different views, linked to the live camera there. It does have this orientation map, which is what we'll focus on here next. And the three sites: Waldron's Ledge, Kupina'ipali over here in the east, Kanakako'i in the south, and Uikahuna in the north. Right, today I have views to share with you from Uikahuna and from Kanakako'i, and we'll try to get you more from Kupina'i maybe in the next week. But this is what I shot last night, 8:30 p.m. at Uikahuna. So you can see that central fountain there, moving lake surface. This is sped up once again by about 20 times or so. So when you're actually standing there, you can't really see the motion. It just looks like it's just frozen in red. But zooming in, just so you can see the central fountains here, and it seems like there are some smaller zones of spattering at the edges of the lake as well, right? So as the lake is coming towards and spilling over or hitting some change near some overflow zone, you might have that spatter on the edges as well. So to play this once again, like just to outline here, that's the main lake oval right in there. And at this point, you can really see two different overflows, one there and a second one over here. You can see it was actually, there's some clouds rolling in here, obscuring things from time to time. And really, it was impressive that as misty or foggy as it appeared to be in Hawaii Volcano yesterday after the talk, I did also cover the After Dark in the Park on Liliuokalani 1917, and after that saw many of the audience walking out and checking out the lava lake, and even with the mist and fog, you could still see all of this. And so it's really, really incredible. So that's the Uikahuna view. We'll turn to, this is a view from a Hawaii Tracker Facebook group by Michael Holsworth. Lava Lake is awake, time lapse from 6 to 7 a.m. this morning from Kanakakoi there. So you really can see there the morning view, pre-dawn view, and interesting inversion layer with a cloud forming right above it there, lit up by the lava. Maunaloa in the background. So really epic views, different every single day for every single person. It's really, really hard to beat. One of the wonders of the world. All right, so this will just keep looping if I allow it to. Let me move on and show one more. Here is a reel from Stefan Hero Welch, also in Hawaii Tracker, and a more zoomed in view, just to show if you have the right equipment, whether it's a scope or binoculars or a nice zoom lens on your camera, or those fancy spotting scopes that have a cradle for your cell phone to go into that you can film this stuff. Whatever it is, bring it, because then you can zoom all the way in and see this really amazing action. That's hard to believe it's happening there all the time, every single day. All right, so that's the viewing update. Viewing is epic in summary here. And so to kind of round it off, let's turn to our earthquakes. And get the earthquakes on our screen here. And here is the last day of earthquakes on island. So you see a couple at Maunaloa, a couple in Kilauea, Fimpahala, not a whole lot. Let me change the settings here to go back to the whole last week. And it populates Kilauea a little more, Pahala more, but really not a whole lot of Maunaloa. So this is Kilauea we mentioned earlier, that pattern. There are still some events happening there, but they're down from before. Maunaloa is pretty much still, right? Not a whole lot to see there at all. I did want to mention, moving on from earthquakes just a bit, because I wanted to mention last week's Volcano Watch article was about seismology and the processes occurring deep beneath Pahala. But this is a throwback, and they're mentioning their deployment of instruments that we're hoping to hear results from at some point in the future here. But they're also going back to this MIT group, I'm sorry, this Caltech group that is looking at that web, magmatic web that we covered in a previous update here. So we'll dive into this again in the future once again, but given a short time today, I don't want to open that can of worms quite yet. Just mention that it is there, and it's on hawaiitracker.com if you'd like to read further. And with that, we'll just touch base on Maunaloa as our last thing here. So coming into Maunaloa Monitoring, last week's report from Maunaloa, since we're doing our updates now, one day off from the update. We'll get another update tomorrow. But no changes are expected here from the one that we saw last week and the week before that. And not erupting, no signs of activity, no active lava, everything's cooling, not active, no tremor, no SO2, H2S or CO2, no seismicity, no deformation. So everything is pretty much nothing. So that's why there's so little to say. I can just show you the one map here. Here's earthquakes on Maunaloa, zoomed in, including the very, very small ones. There are some there, right? But it's really nothing compared to what you see when it's building up to any kind of action. So it's certainly still looking like it was spent and is in its recovery phase now. And even so, just to remind you, we have seen these stretching of the summit for years following both the 75 and 84 eruptions. And so even if it starts stretching a little bit, that's not on its own enough. It's more about the overall pattern that we'll have to build up once again, earthquakes and stretching all at the same time. So that's Maunaloa, apart from mentioning that there is ongoing community outreach as well. Kind of falls right in line with Maunaloa. We want to be prepared for all the potential future eruptions of Maunaloa still. Learn from the lessons that we've seen here in the end of last year, Dane. And there is a Kīlauea Resilience Fair this coming Saturday, 10 a.m. to 2 p.m. at the Maunaloa Resilience Hub. And similar to the other events that have happened island-wide. And so here's one more. This one's in Kau, and next week, just to throw it out there since we have it as well, at Lapa Hoihoi, the 28th, 10 a.m. to 1 p.m. at the Congregational Church up there. Hosted by Vibrant Hawaii, Resilience Hubs, and this is a great chance to come in and talk story with all the different aspects of emergency response and preparedness there. That's the Community Resilience Hub. We did mention Volcano Awareness Month calendar already once again, so just to recap what's happening in the future now, coming up shortly on Naleo, 6 p.m., Maunaloa 2020 Eruption and Response. Tomorrow, Maunaloa Geochemistry, and from what we've heard, a comparison to the 2018 eruption of Kilauea. On Sunday, there is 2 instances of the Mauna hike, led by Dr. Carolyn Parchetta. It's a fantastic hike that we've been on before. She's done a lot of research, actually developed a little robot that can crawl down into cracks in the fissures and measure the width of the cracks in an area like that. So she talks about that, actually shows you the robot, and talks about how the fissures come up and how they initiate, how they relate to 2018, 2022, 2023, all of that stuff. So check that out if you can. I'm not sure we'll be able to actually stream that one. We'll see, but that's might be a tough one there. And then we'll resume in a national park after dark in the park next week, Tuesday, with Maunaloa Eruption Insights and following Kilauea. So that is the rundown, Dane. I think that is it. If we're going to do some thank yous, some discussion, some questions.
Yeah, we got a few minutes here at least. All right, so we'll try and first shout out everybody that's here. Appreciate you all tuning in. You know, we rely on viewers like you to really get the message out there, to, you know, share it and help get the algorithm going with the likes, subscribes, comments. All that stuff does help. Like, it really does help. So appreciate everybody that tuned in today. And, you know, it's really in times like this where you get the education for the next eruption, right? When the eruption happens, like when Maunaloa goes, or we get another, you know, rift zone eruption on Kilauea, it's all the knowledge you got beforehand. A bunch of people come in and, you know, want to see the flashy lava, but to understand what's actually happening, this is, you know, the part where you put in the time. So appreciate everybody that tuned in for this. We also a lot of thank the County of Hawaii through the Bye Bye grant. They've helped ensure this type of content is possible and keeps us going with content production on Hawaii Tracker, on the YouTube Hawaii Pod, and also on the Facebook group Hawaii Tracker. So we appreciate County of Hawaii, and yeah, the resilience hubs, all that. It can all works together, right? Where there's a whole bunch of projects going on, and we appreciate them, you know, stepping out and funding our projects. So yeah, we appreciate them. And I think we had a couple of super chats as well. Gary Bryan, a longtime supporter, came by and dropped a $35 super chat. He says, thanks, Phil and Dane, for all you do to help us stay informed. Appreciate it there, Gary. Good to see you again. And then Christopher with a $19.99 super chat says, aloha, Dane and Philip. A few months back, there was a lava lake level drop and an intrusion event. Has more information come out about this event and the volume of the lava involved?
That's a great question. We never got a follow-up from that exactly. I did have some calculations of my own that I think put it at something like a few million cubic meters, right? So it was I want to say 5-ish. We'll have to look it up again, yeah. But that was making some assumptions of the previous rate having led to right up to that event and then continuing afterwards, right? And the trick to that now is that in hindsight, we see that it was all a response to Mauna Loa's impending eruption at the time. So we know that the subsurface changes were not just something trivial with like a changing of the pathway within Kilauea just by itself. It was because Mauna Loa was putting all that pressure in it there too. So that complicates things a lot there, right? And it's hard to make any assumption that that rate kind of went the same, but what we can say for sure is that Kilauea never really recovered after that, right? I mean, she's basically slowed. There was still circulation at that open western pit, but the crater floor really wasn't rising up as much anymore after that. right? So it was able to find more space deeper underground rather than come towards the surface. So while the input to the volcano from deep down was likely still the same, between that shallow reservoir and the actual surface, that rate, right, that's the one that would tell us, how much is in the lava lake, how much is in placing, is it draining, all of that. Like, that's the one that's more questionable there. So it's a great question, but that's the discussion that I can offer for it, and no answer, and we haven't seen anything specific as far as volume. We did see one Volcano Watch article that described it being somewhat like a sill, right? Some horizontal layer structure that seemed to inject underneath that western part of the lava lake area. But it was pretty far down there, right? It wasn't like directly where, if you're imagining the lava lake in your head, it wasn't like next to that. It was deep down below that western edge of it, within a harder rock, way down below. So yeah, that's what I can offer for review of what's been said. We haven't got a volume in particular, but great question. I think from what I remember talking to Mike Zoller, there was so much going on, they weren't able to fly the drones to get the DEM measurements as frequently as they would have liked, right? To get that resolution, to know, okay, well, this is what it was just before, and this is what it was just after, and therefore this is how much it actually went in between. So that's just something we'll have to estimate some other way, unfortunately.
All right. I got another question here. Richard asked, Mauna Loa stopped erupting, but what's happening with the magma level in the vent? I'm assuming he's talking about Fissure 3. Does it draw down, or is it just sitting there at a certain level?
Yeah, well, usually what happens is it draws down to some lower level that's like where the rift zone itself is, right? And so the rift zone is kind of always has some active magma in it, you imagine, right? And that's down about a half mile down. So depending on exactly the dynamics of an eruption, Mauna Loa is bigger and behaves in ways that we're not as familiar with there. There hasn't been any glow at the surface that we can see. There's been no gas emission at the surface, and you'd imagine if there's gas emission and glow, then there's a pathway to actually look at or see some of that lava. But if you don't see any of that, then it must be sealed off. So as it retreats back down, it kind of hardens and encases itself, and so it's still liquid deeper down, but you can't really see into the glow or see that area. So that's how far down it is. I would estimate half mile, just ballpark, because that's where the rift zones, that's what makes the rift zones, is all the remnant magma from all these eruptions that feed through there.
One thing I was wondering is, we were talking about this in the Ocean View meeting. It was pretty intimate with Ken Hahn. Just, we got to ask a few questions. So we were asking about the rift zone, and particularly why the trace of magma that we saw in the beginning of 2018, the residual magma from the past eruptions, wasn't seen on Mauna Loa, right? And that had to, they're mentioning that had to play into the way Mauna Loa is fundamentally different, the rift zone. It doesn't store like Kilauea does, they were suggesting. So I was wondering, does that fall deeper then than Kilauea?
Yeah, it's a bigger mountain. You might imagine the rift zone is taller, perhaps. I don't know. It's just one thought there, right? It's not that all eruptions of Mauna Loa have that character, but it's the high elevation vents of Mauna Loa in particular that don't often show that remnant magma trace, right? So it sinks down low enough that when it comes out of the high vents, it doesn't get scooped out. But when it pushes further east on a rift zone towards Hilo, let's say, and pops out lower down in the mountain, that's when it scoops out the stuff. So it's still in there. It's just like big enough that it can separate. Yeah, find a path.
The dike is and the higher elevations propagates above the level that the storage is taking place, basically.
It may. I mean, it's hard to know, right? But certainly it's a distance between that storage zone and a surface where even if that storage stuff is getting stirred up for some reason, it's not getting to the surface. Yeah, I think that's basically it. And we better wrap it up to give us time to find and share the links to the Naleu talk here. And
that should be good. I was hearing Ken Hahn should be talking on that one. So yeah, not exactly sure the entire lineup, but it will be interesting to see what they have in store.
For sure. So we are still on for next week, Wednesday, I believe. Yeah.
Yeah.
And so we'll see you guys then. Unless something dramatic happens in between, we'll just keep tracking what's happening. And educating so we can all be better prepared for future activity in Mauna Loa, doing outreach at these in-person events, these talks as well. We appreciate the USGS Hawaiian Volcano Observatory for Volcano Awareness Month and all that outreach that's happening extra this month. So until next week, from HawaiiTracker.com, he's Dane DuPont. I'm Philip Ong. Aloha, everybody.